For the Nernst Lab, I think students have been having trouble calculating Q. In this lab, we have two ions. We have copper 2 plus and zinc 2 plus. And then we have our solid electrodes, whether they're the anode or the cathode. So something that you need to know, regardless of how you're changing the concentrations. Q in this case is going to be the concentration of zinc over the concentration of copper. And here we're talking about the ions. So in one part of the experiment, you're going to hold the copper constant. So this is equal to 1. So your Q is just equal to your zinc 2 plus concentrations. And in the second part of the experiment, the relationship is the same because it's the same reaction. You are holding the zinc equal to 1. So then your concentrations of changing copper or changing concentrations of copper ion are on the bottom. So your Q will be different. So in part 1, you found that Q just equaled your concentration of the zinc 2 plus. But in part 2, you're going to find that Q equals 1 over your concentrations of the copper 2 plus. So that will change how you think about your calculations in that section. The other common question that I have received is how to determine the number of electrons. So if we get rid of these marks so I can show you. All right. So zinc, going to zinc 2 plus, we see it's going from 0 to 2 plus. So that's 2 electrons. And then from copper 2 plus to copper 0 is also 2 electrons. So this equation or reaction is balanced, and it's balanced with 2 electrons. So in this case, N equals 2. And that's the actual. In the experiment, you're using the equation that you were given to help you find the number of electrons. So that equation is E equals E cell E equals the standard E cell minus RT over NF, natural log of Q. So when you graph it, you have Y equals MX plus B. So your slope is related to the number of electrons, and you're going to calculate the actual, the experimental in from your equation of the line, and that's not going to be a whole number. And then you can compare it to the actual number of electrons to get a % error. And then your E cell, standard E cell, is just equal to the Y-intercept.